Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, let's see how you did on the homework. It says use a graph to find the distance between these 2 points. Okay, so here we're doing kind of a Pythagorean theorem process on a coordinate grid. And you'll notice I've shown this to you once before. This is what you call the distance formula for points on a coordinate grid. And it's very much like the Pythagorean theorem in that you've got a right triangle that essentially can be created with this diagonal line on the coordinate grid serving as the hypotenuse. So you've got the distance, the vertical distance between C and D, and you've got the horizontal distance between C and D. And so the x values are going to give you your horizontal distance. So what's the distance between -4 and 4? It's a total of 8, right? And so that's what you've got here is you're taking 4 minus a -4 to give you 8. And then you're going to square that. And then the vertical distance is going to be the difference between -1 and +1 on this coordinate grid, which is like your y2 minus y1 is 1 minus a -1 gives you 2. And so that's 2 units here. This was 8 units there. So there you've got your 2 sides of the right triangle, the 2 legs, and then we're going to square that. And then after going through this process, this being 64, this being 4, then you add them together, eventually the hypotenuse, which is C, is going to be equal to the square root of that sum. So in this case, D stands for the distance from this point to this point. Whereas using the Pythagorean theorem, a squared plus b squared equals c squared, c is the length of the hypotenuse, which is that line. So what is the square root of 68? I'm wondering, yeah, no, that should be right. 68 square root, where are you, square root button? Where are you, square root button? Are you on the regular calculator? There you are. Stop it. 68 square root of that, yeah, 8.4. Ooh, why did I round that to 0.4? That should be 0.5. 8.25 units. Okay, so we got that straight. So as you get into high school a little bit more, you'll be using this algebraic formula, which is essentially Pythagorean theorem for coordinate grids. Jack has a tree in the back of his yard he wants to cut down to ground level. He needs to know how tall the tree is because when he cuts it, it will fall toward his fence. Jack measured the tree shadow and it measured 20 feet long. At the same time, Jack's shadow was 12 feet long and Jack is 5 feet tall. So remember, this is what we refer to as indirect measurement, where the sunlight from that beam that's coming down, forming the shadows, is a straight line, which kind of serves as a hypotenuse because trees grow perpendicular to the ground. Assuming the ground is flat ground, it's gonna grow straight up toward the sun. And then you're standing straight up, or this dude is standing straight up. He's 5 feet tall, so his shadow was 12. So that's a ratio of 5 feet for him for 12 feet for his shadow. And we don't know the height of the tree, but the tree's height is proportional to its shadow just as the person is, because these are what you would classify as similar triangles. Remember, angle similarity here. They're both right triangles, so they've got this angle similar, and then this angle that comes off from the sun is going to be the same for both of them, and this angle is the same for both triangles. So all 3 of them are the same, meaning that these 2 triangles are similar, which means this is proportional in nature. So when you cross multiply, you get 12x is equal to 100, and then 100 divided by 12, 8.3. So how tall is the tree? It's about 8. We could have said 8 feet, and what is that, 3 repeated? So that's 1/3 of a foot, which is going to be So really, it's 8 feet 4 inches. Will the tree hit the fence if the fence is 9 feet away? Nope. You're going to have 8 inches to spare. All right, take a look at the diagrams below. Are we solving for x here? What is the relationship from the measure? Well, these two angles are across from each other. When two lines intersect each other, the angles across from each other are called vertical angles, and they are congruent to each other, which means this is going to be equal to that, which means by the time we take away 3x's from each side and add 57 to each side, you're going to have 2x's is equal to 62, so x equals 31. Here, when you got two lines that intersect each other, the adjacent angles are always going to make up a 180-degree angle, right? Because that's a straight line. So that means they're supplementary. So this plus that equals 180. So you're going to get 6x's plus 150 is 180, which means 6x's is equal to 30 by the time you take 150 away from 180. 30 divided by 6 is 5. On paper, graph the system of equations, state the solution. All right, well, these two lines are parallel to each other. They are never, ever going to intersect each other. So that means that there is no solution, because the solution to the system of equations is the intersection point of those two lines. They never intersect. There's no solution. And I feel like we've seen this before. I can't remember. All right, so the principal made a histogram to analyze the number of years the teachers have been teaching at the school. So there's that goes to 7, this goes to 10, to 4, to 1, to 2. By the time you add them all together, that's 24 teachers. So what's the probability if you randomly chose a teacher that they had been teaching for more than 10 years? Okay, so technically, I've had students bring this up in the past. A teacher that had been teaching for 10 years would go in this category. And so maybe one or more of these 4 actually have only been teaching for 10 years, which this says more than 10 years. So I get that argument, but I'm going to assume that they really meant to say 10 or more years, because that would mean this guy, or those people, those people, those people. So that's 7 out of the 24, which would be about 29%. Let's take a look at that. 7 divided by 24 gives you the decimal of 0.2916 repeated. So you move that 2 places to the right, so that's equivalent to 29.16 repeated. I just rounded it to 29. So what's the probability that a teacher on the staff has been teaching for fewer than 5 years? Well, this is definitely the one that's fewer than 5 years, because if anyone's been teaching 5 years, they're going into this bin right there. So 7 out of 24, same exact ratio, same percent. And then the last problems. I'm only going to do one of these. I'll just note that whenever you're dividing problems that have the same sign, you're always going to get a positive answer. And if you're dividing two numbers with different signs, just like when you're multiplying, they'll have a negative answer. So just forget about the negative sign for now. Sometimes what I'll do is this. I know that one's going to be negative, so I'll put the negative sign in my answer box so I don't forget it. But when you're dividing fractions, there's a process. There are a couple of different ways you could do it, but the one that we teach most often is just multiply times the reciprocal. So you end up with 120 over 35, which can be simplified and changed to a mixed number. If you might recall, some of you last year in 7th grade preferred to do this where you got common denominators. So if I rewrite this as 24 over 10 divided by 7 over 10, then I don't have to multiply times the reciprocal. I can just do the division. So 24 divided by 7 in the numerator and 10 divided by 10 is 1. And since we know anything divided by 1 is going to be equal to itself, we can just ignore that, and that's how you get your 24 over 7. Okay, so you go through the same processes for these two, multiply times the reciprocal or get common denominators and divide. These will be your answers. Okay, I think that's it for the day. Good. Okay, so today is the day to just work on the study guide. Make sure you understand Pythagorean theorem. You find my study guide on the Google Classroom, and then tomorrow is going to be the Chapter 9 test number 2. So good luck with all of that. Hope you're understanding everything as well as you can. Take care.
Hey, feeling good, like I should. When in dark, walk around the neighborhood. Feeling blessed,